Dreamers, this is Ravindra Thube, faculty at BYJU'S Exam Prep, and you're watching a 60 mark series. So today we are talking about machining topic. It is very important for GATE examination. Let's welcome the participants. Whoever is joining, just mark your presence by liking session or comment something so that I'll understand who is present there. So we'll get a feeling that, and then we'll kickstart our session. Okay, Kiran, hi Kiran. Rest of the students who are present, please mark your present by liking the session or just comment on that so that we'll start our session. Right, fine. Am I audible to everyone and my PPT is visible? Yes, all good, sir. Yes, fine. How is voice? Is it good? Voice is good? Right, fine. So let's start now. We'll talk about lathe machining operation and we'll try to solve certain questions from a lathe machining operation. Lathe machining operation. Let's see that the first question is coming on the lathe machining operation. What is it? A non-standard thread. What is the question is there? Let's see that. A non-standard thread of pitch 3.175 mm is to be cut on the lathe having a lead screw of pitch of 6 mm. A change gear set provided with the lathe has one gear each with the following number of teeth 20, 30 and so on, and one special gear is given 127 teeth. The correct pair of change gears, that is A by B into C by D, which means that compound gear train we have to design. Right, fine. For machining the given thread, or assuming that the transmission ratio of the rest of the kinematic train between the lathe spindle and the lead screw is exactly equal to. So gear ratio we have to calculate. So number of options are given. So whenever we are interested to talk about the gear ratio, we know that. So whenever I'll write down the gear ratio, it's a very simple that. What is the gear ratio? So I'll say that, sir, gear ratio is coming exactly equal to, gear ratio is exactly coming exactly equal to number of teeth on the driver gear, number of teeth on driver gear, number of teeth on driver gear divided by number of teeth on a driven gear. Right, number of teeth on a driven gear, driver gear divided by driven gear, which is exactly equal to a pitch of job divided by pitch of a lead screw, divided by what? A pitch of a lead screw. We know that, sir, gear ratio is different and the speed ratio is different. You have to differentiate between them. So I'll say that the gear train is exactly equal to number of teeth on the driver gear divided by number of teeth on the driven gear, and the pitch of the job divided by pitch of the lead screw. Pitch of the job divided by pitch of the lead screw. So I'll say that, sir, it is exactly equal to, how much is the pitch of the job? If we go back, you'll understand that, sir, pitch of the job is exactly equal to, that is workpiece. Pitch of non-standard thread of pitch is 3.17 is to be cut. Right, fine. So pitch is exactly equal to 3.175. 3.175 millimeter divided by the pitch of the lead screw. So what is the pitch of the lead screw? Is given 6 millimeter. Is it okay, everyone? 6 millimeter. Hello, sir. How are you? Yes. Rajat Mishra, great. Shubnit Kaur, yes. Yes. Okay, fine. So all the participants join, right, fine. So now we want to convert that. Whenever there is a odd number of pitches given, that is 3.175, always check with that whatever 127 gear teeth is given, that has to be have a particular role in here. So I'll do one thing, that I'll multiply by 40 and divide by 40. What I'll do, I'll multiply by 40 and I'll divide it by 40. If I multiply by 40, I'm damn sure that it will come 127 divided by, I'll say that 40 multiply by, I'll take the 6 as side. So I'll say that 1 by 6. Now, is there any gear which is having one number of teeth? Is there any gear which is having a 6 number of teeth? It is not available. It is not available. So can I say again we have to do multiplication or simplification. So I'll say gear ratio is exactly equal to 127 number of gear teeth is there. A special gear was having 127 number of teeth. 40 is there, right? Compound gear teeth 1 by 60. So whatever this 1 by 60 is there, you multiply by 20 and divide it by 20. Multiply by 20 divided by 20. So once we multiply by 20 and divide by 20, so I'll say gear ratio is coming, a compound gear train combination, 127 divided by 40, that is A by B, multiply by 20 divided by 120, right? Fine. Do I have a gear who has 127 teeth? Yes. Do I have the gear who has 40 number of teeth? Yes. Do I have the gear who has a 20 and 120 number of teeth? Yes. So A by B multiply by C by D is exactly this one. So therefore, if I go back, what will be answer is coming? So I'll say that my answer is coming exactly equal to, what is my answer? So this will be C is exactly equal to answer. This is what exactly ratio is there. Which book? There are different books are being used, Nasim Khan. There are different books are utilized. So you have to use the number of books as far as topics are concerned. Metal cutting and machining operation generally, there is one scintillating book for metal cutting operation, which is nothing but Amitabh Bhattacharya. And machining operation, Hajra Chaudhary is also good. Even Kalpak Jain is good. Michael P. Grover is also good. So option number is what? C. Kiran Kumar, Bombay B. Bombay B is there, not C. Bombay B is there. Right point. C is not correct one. Right point. Yes. You can follow this book. What book follow karni chahiye, sir? Yes. But I think so for GATE examination, I don't see that you have to follow the book. You follow the notes because book has very vast fundamental knowledge and it consumes a lot of time. It consumes what? A lot of time, I would say. So therefore, you restrict yourself to, I would say that concepts only. That's better. Next question is coming. What is it? It is required to cut a screw thread. It is what? Required to cut screw thread with a double start and 2 mm pitch on a lathe having lead screw pitch of 6 mm. What is the speed ratio between the lead spindle and lead screw? And we know that the speed ratio is opposite of that gear train ratio. You have to understand that speed ratio is what? Opposite of that. So what will be exactly to speed ratio is coming? What will be exactly to speed ratio is coming? You tell me that. So I'll write down here. The speed ratio is exactly equal to, speed ratio is exactly equal to what? Number of teeth on a driver gear. Number of teeth on what? Driver gear divided by number of teeth on a driven gear. Number of teeth on what? Driven gear. It is exactly opposite of gear ratio. Right, fine. It is exactly equal to pitch of a lead screw. Pitch of what? Lead screw divided by the pitch of the pitch of a job. Pitch of lead screw divided by pitch of job. Pitch of lead screw divided by pitch of job. And previously, when gear train ratio, we have discussed that pitch of the job divided by pitch of the lead screw. So gear ratio and the speed ratio both are different. They are what? Exactly opposite of that. I have to say like this. So therefore, I'll say that speed ratio is coming is the pitch of the lead screw. What is the pitch of the lead screw? It is given it is required to cut a screw thread with a double start and 2 mm pitch on the lathe. So pitch, it can be also reframed as pitch, nothing but I'll say that lead of lead screw. Lead of what? Lead screw. Right, fine, because double start thread is given divided by lead of job. Divided by what? Lead of a job. Lead of what? Job. What is the lead of the lead screw? Sir, lead of the lead screw will be 6 divided by lead of the job, double start thread, and pitch is equal to 2. 2 multiplied by 2, it's 4. So it is coming exactly equal to 3 by 2, 3 is to 2. 3 by 2, 3 is to 2. What is the answer, Kiran Kumar? 3 by 2 is coming here, Kiran Kumar. How is it B? B is not coming. B is not coming. What is coming? It is asked what it is asked. Speed ratio is asked. Speed ratio. What is speed ratio? That is nothing but lead of the lead screw divided by lead of the job. Number of formulas are there that you have to tackle that particular point. 3 by 2 answer is coming. Okay, fine. So I'll say that not only that 3 by 2 Delhi D is correct one. Next question. These are all collected from the lathe machining problems. A shaft of length 90 mm, has a tapered portion of length 55 mm. So shaft is there of 90 mm, but out of that only 55 mm is having a tapered length. The diameter of the taper is 80 mm at one end and 65 mm at the other end. So whenever taper is created at one end, 80 mm diameter, other end 65 mm diameter is made. By the tailstock set over method, the taper angle and the set over respectively are. So how much is the offset that we need to create it in minimum millimeter, and we are interested to calculate a what is that taper angle. Taper angle we are interested to create. So can you able to calculate? Figure is in front of you. Right, fine. Figure is in front of you. So now I'll do one thing that, sir, first of all, if I want to calculate taper angle, let's say that, sir, capital L stands for a length of exactly equal to length, capital L is the length of the object, length of the workpiece. Length of the workpiece is 90 millimeter. Length of the workpiece is 90 millimeter. Is it true? Yes. And over a small length of 55 millimeter taper is collected. So small l is exactly equal to taper length. Taper length is what? Small l. Okay, fine. Now one side diameter of the taper is exactly equal to 80 millimeter, and one side diameter, that is di or do and di, you can use anything, no problem, or d initial and d final, original and final. Let's say that's 65 millimeter. 65 millimeter. Is it okay? 65 millimeter. Is it true? Yes. Now whenever figure is given, first of all, how to calculate taper angle? Sir, now this is what exactly I am drawing a horizontal line here. This is what exactly. So I'll say that this will be half of the taper angle. Let's say that theta. Theta will be what? Half of the taper angle. Now if I calculate tan theta, can I say that this will be a 90-degree angle, right? Right angle triangle. So if I draw this figure here, you'll also understand that, sir, for calculation of taper angle, right, fine, I'll draw horizontal line, right? I'll get 90-degree angle, right, fine. This is the small l, which is exactly equal to 55 millimeter. Capital L, that is the entire length of object, right, fine. Smaller diameter, this final diameter or original diameter is 80 millimeter, and the final diameter of the taper df is coming exactly equal to 65 right, fine. So if I want to calculate this half of the taper angle theta, so can I say I have to use one equation? I'll say that tan of theta is exactly equal to outside diameter minus, or original diameter minus final diameter, d naught minus df, divided by what? Divided by twice the small l. Why 2? Sir, where to practice MSQs? Multiple select questions has to be practiced. I don't know that why the multiple select questions are creating so much of hava, because till now I think so in entire GATE examination only 2% or 3% questions were asked MSQs, and everybody is talking MSQs. Is it like that? Entire GATE examination MSQs are coming. So it's not like that. We can practice MSQs from the BYJU'S Exam Prep. We have a number of good MSQs are selected, so you can practice from there, or you can practice previous year engineering services, but these are all theoretical questions, right? Fine. Okay, we'll take the MSQs. We have started MSQ series in mechanical also. We'll come that MSQ series. No worries. Right, fine. So what is that? D naught minus dm divided by 2l. So I'll say that tan of theta is exactly equal to d naught is what? 80 minus d final is 65 divided by 2l, right, fine, divided by 2 multiplied by l, that is what exactly equal to again 55. So therefore I'll say that theta value is coming. How much theta is coming? If we calculate that, theta is coming 7.76 degree. So what is the taper angle? So can I say total taper angle has to be double of that. It is only one half of the taper angle calculated. So I'll say that, sir, taper angle will be exactly equal to 2 multiplied by this theta, which is exactly equal to a 15 degree 31 minute. 15 degree 31 minute will be answer is coming. So this is what exactly my answer is coming. Right, fine. Now we are interested to calculate offset. So how much is offset? Offset has to be calculated based on the entire length of the body. Right, fine. So I'll say that, sir, from here to here, length of the workpiece is capital L, which is exactly equal to 90 mm. Length of the workpiece capital L, that is exactly 90 mm. So this angle, I would say that a right angle triangle. Right, fine. Right angle triangle. Now what will be this angle? If I talk about this angle, can I say that will be theta? That will be half of the taper angle theta. That will be half of the taper angle theta. Yes or no? This is horizontal, this is parallel. Yes. Half of the taper angle. So now we are interested to calculate this particular x. This particular x. X means what? The offset distance. So I'll say that from this, sine theta is exactly equal to offset distance x divided by length of the workpiece. So I'll say that, sir, x is exactly equal to L into sine theta. L into what? Sine theta. So x is exactly equal to L stands for 90 multiplied by sine of theta, and theta is coming exactly equal to 7.76 degree. So x value is coming, how much is coming? 12.15 millimeter. This is what exactly answer is coming. Is it correct, everyone? So what is the answer is coming? Let's see that. So absolutely correct. This is what exactly answer is coming. Kiran Kumar, yes, very correct. Kiran Kumar, absolutely correct. Right, fine. Naseem Rajat Mishra, absolutely correct. Right, fine. Shall we go to the next question? Yes, fine. So we'll go to the next question now. There is a disc of 200 mm. But you have to do a practice, Rajat. You have to do a practice, right? Without the practice, it's highly impossible, right? Fine. A disc of 200 mm outside diameter and 80 mm in diameter is faced at a feed of 0.1 mm per revolution with a depth of cut of 1 millimeter. The facing operation is undertaken at a constant cutting speed of 90 meter per minute in a CNC lathe machine. The main and tangential cutting force is given exactly equal to 200 Newton. Assuming approach and over travel of the turning tool to be 0. There is no approach and there is no over travel, right? Fine. During the machining operation. So what will be the machining time in minutes? Inside diameter is given, that is 80. Outside diameter is given, that is 200. And we are interested to calculate what? The time required for machining operation. Very interesting question. Right, option number C. Let's say that what is exactly answer is coming. So we'll write down the data first of all. Whatever data is given, that we'll write down. So if I write down the data, I'll say that, sir, original diameter or outside diameter is 200 mm. And inside diameter DI is given exactly equal to 80 mm, right? Outside and inside diameter is given. The feed value is given exactly equal to 0.1 mm per revolution. Per what? Revolution. The depth of cut D is given 1 millimeter. Cutting velocity is given 90 meter per minute. 90 meter per minute is cutting velocity. What is data given? I am writing down the data. You can check the data. Cutting velocity is given 90 meter per minute. Right, fine. Cutting force is also given, but I don't require to use the cutting force as far as that machining time is concerned. Right, fine. And what is the formula? So I'll say that machining time calculation is exactly equal to, right, pi divided by 4 into F into V. Pi divided by 4 into F into V multi into D outside square minus D inside square. This is the formula developed. Is it the formula? Yes, Kiran Kumar, I think so. You are absolutely correct. Kiran and Rajat, absolutely correct, Rajat. Right? So I'll say that, sir, pi divided by 4 into F into V into D outside square minus D inside. These are the formula has to use. So I'll say that, sir, machining time is exactly equal to pi, right, fine, divided by 4 into feed. That is what? 4 into feed. What is the feed? 0.1 mm. Velocity 90 meter per minute. You convert into mm, so multiply by 1000. Multiply by 1000 by converting what? By converting this particular 1000. You have to multiply by 1000. Don't forget that. And outside diameter is 200 square minus inside diameter is 80 square. Right, fine. So therefore machining time calculation will come exactly. What is the answer is coming? I think it is coming 2.93 minute. 2.93 minute. 2.93 minute. Is it correct, everyone? 2.93 minute answer is coming. No doubt into it. Right? Fine. Swati Kumari, very correct. Rajat, Kiran, and Naseem. Fine. We'll talk about now next question. Right, fine. Determine the transformation ratio, that is gear train ratio or gear ratio. Transformation ratio is the same thing, right, fine. Of a gear train connecting the spindle and the lead screw of a 4 TPI, and TPI stands for thread per inch. TPI stands for thread per inch required to cut 1.0 mm pitch screw threads in a center lathe. In what? Center lathe. So you are interested to calculate that, right? There is one formula, train ratio. What is that? You solve it. I'll just come in 1 second. So is there any answer is coming here? Is there an answer is coming over here? So I know that what is the formula? There is a master formula already developed and discussed. That is nothing but a train or transmission ratio is exactly equal to 4 into small n into P divided by what? 127 threads per inch. Thread per inch. Whenever such formula is coming, this is what exactly our question is coming. This we have to utilize. That's it. So I'll say the train ratio is exactly equal to 4. How many number of threads? 4 per inch, or sorry, 4 threads per inch. What is the pitch? Pitch of the thread is 1 millimeter divided by 127. 127. Is it true? Sorry, it is 5 NP, not 4 NP. It is 5 NP. So I'll say that's it has to be 5 into N into P, and N stands for number of tracks. Rajat Padlo. Yes, 20 by 127. Very correct. So train ratio is exactly equal to 20 divided by 127. Very correct. 20 divided by 127. 20 divided by 127. Is it okay, everyone? Right? Very good. Very correct. 20 by 127. Now this is just a chiller question. A cold forming process in which a hardened tool is pressed against a workpiece. Hardened tool is pressed against the workpiece. When there is a relative motion between the tool and the workpiece takes place to produce a rough surface with a regular pattern. So we know that, sir, whenever the hardened tool is pressed against the workpiece, right, and in the cold forming operation where the regular pattern is created, it is nothing but called as knurling operation. And we know that knurling is not a machining operation. Knurling is always what? Knurling is always my forming operation. Knurling is what? Always my forming operation, because there is just a displacement of material takes place. There is not a removal of material takes place. Is it true? Yes. Swati, Farad and Kiran, Naseem, everybody, I'll say that, sir, it is exactly equal to what? Knurling operation. So A will be my scintillating answer. Right? Fine. I hope so you are understanding this. Next question. Now the next question is very simple, that the preferred option for holding an odd shape of a workpiece. So how this particular odd shape of the workpiece will be get held into the lathe machining operations, whether you use a live and dead center, 3-jaw chuck, a lathe dog or 4-jaw chuck. So we know that for holding of the workpiece, champering ka diagram, sir, right, for holding of the workpiece, can I say that, sir, there is chuck is utilized. But we know that 3-jaw chuck is basically utilized for holding the cylindrical shape of the workpiece or symmetrical workpiece, generally cylindrical workpiece. Whenever there is an odd shape of the workpiece that we want to hold, then can I say that 4-jaw chuck we have to utilize. So answer will be exactly equal to what? 4-jaw chuck will come in the picture, right? So irregular shape, odd shape of the body, whenever we are into hold into machining operation, so delete will be correct answer. Absolutely correct. Right. Now we'll talk about and solve some questions based on a lathe machining operation. Which one is that? Shaping, planing and the slotting operation. Right. Refresh your memories and fundamentals. Let's solve the numericals now. What is it? A workpiece of 2000 mm length and what? A 300 mm width. So there is a workpiece whose length is 2000 mm, and the width, there is a rectangular face of the workpiece is there. Shaping and planing is nothing but utilized to generate the flat shape. Utilized to what? Generate a flat shape. Right? Fine. So width was machined by a planing operation with the feed set at 0.3 mm per stroke. 0.3 mm per stroke. If the machine tool executes 10 double stroke per minute, and double stroke means what? Forward stroke plus return stroke. That is called as cutting stroke plus return stroke. That is nothing but called as what? A double stroke. And we know that crank has to be rotated one rotation. One rotation of the crank, tool will move forward as well as backward. Is it true? Nora Fateh is also joined? Absolutely. Yes. So the planing time for the single pass will be. So how much time will be required for planing operation? An answer is coming Bombay B. All of students absolutely correct. No doubt into that. Because we know that whenever we are interested to calculate the time required, it was given that in a 1 minute 10 double stroke. That is nothing but 10 stroke. Definitely you can calculate that. So crank is rotated 1 times, 1 double stroke. So now we are interested how many number of double strokes are required. So if I am able to calculate double stroke, then I will be able to calculate how much time is required for machining operation. Now sir, the feed is 0.3 mm per stroke. So tool is going forward, coming back. Then again speed is given, again going forward, coming back. So one stroke may 0.3 mm width of material is getting cut. So how much is width? 300 mm. So you tell me that how many number of strokes are required. So I'll say that number of strokes required exactly equal to 300 divided by 0.3. 300 divided by what? 0.3. This is exactly equal to number of strokes are required. Number of strokes required exactly equal to 300 divided by 0.3. So that means, can I say that 1000 number of strokes required, 1000 number of strokes required, so that this entire width will get machined. Because length we should not consider, width we have to consider. Width has to be important. So if the 1000 strokes required, 10 strokes to generate 1 minute is required, because 1 minute 10 strokes to generate 10,000 strokes, how much time is required? So can I say time required is exactly equal to 1000 divided by 10, which is exactly equal to 100 minutes. 100 minutes. Is it understood? So answer will be exactly equal to 100 minutes. So I'll say that this will be my answer. This will be my answer. 100 minutes will be required. Is it okay? Sir, punching and piercing operation में क्या difference है? We are talking about machining operation, right? Fine. Punching and both piercing operations are considered as synonyms. Generally, what is called as piercing, we say that nose is pierced. Nose is pierced. Nose is not punched. Do you do a punching on the nose? No. But the sheet, if there is one sheet paper is there, we do a punching. So during the punching operation, removal of material takes place. But in the piercing operation, removal of material doesn't take place generally. No removal of material takes place in piercing. Right? That's what the difference between punching and piercing operation. Now, again, one very interesting question is asked. Right? What is that? The ratio of time of a return stroke to the time of forward stroke. Return stroke to the time of forward stroke of a shaping machine is 0.6. And we know that time required for return is greater and time required for cutting is higher. Right? Absolutely correct. Because return stroke, there is no contact between tool and the workpiece. So therefore, there will be no machining operation. The tool will be moving in a higher speed. Right? Fine. The stroke is a 500 mm and it makes 15 double stroke per minute. So stroke length, it's not stroke length is 500 mm and it makes 15 double stroke per minute. So in one particular minute, 15 stroke. Double stroke means forward plus backward. That is called as double stroke. What is the overall average speed of the operation? What is the overall average speed of the operation? Can you able to calculate what is the overall average speed of the operation in this particular case? We know that, sir, what the data is given, I can easily write down here. So I'll say that, sir, M value, because it is opposite of that particular ratio, right? That is what exactly I'll say, that shaping ratio. So I'll say that time of return stroke, time of what? Return stroke, divided by a time of cutting stroke, which is exactly equal to 0.6. When this value is less than 1, it is being nothing but called as M value. And what is given, length of the stroke is exactly equal to 500 mm length of stroke, and 15 double stroke per minute. So can I say that whenever the crank is rotated one time, there will be double stroke forward plus return. Then in 1 minute, if there are 15 double stroke, that means what is the RPM of the crank? Can I say RPM of the crank will be exactly equal to N. RPM of the crank is exactly equal to 15 revolution per minute, right? Fine. And velocity, what is the formula? The velocity is exactly equal to N into L into 1 plus M. Have you heard about this formula? N stands for RPM, L stands for length of the stroke, 1 plus M is nothing but reverse of that particular quick return ratio. That is called as QRR. M is nothing but what? 1 by. M is nothing but what? 1 by R. 1 by R. And quick return ratio is nothing but what? Quick return ratio is nothing but time of cutting divided by time of return stroke. And it is always greater than 1. But M is always less than 1. I hope you are understanding. Rajat Mishra, I think your answer is correct one, I think so. I think so, 12 meter per minute. Very correct. Naseem, Nora Fateh, Swati, Farad, absolutely correct. Right, fine. So if I put all the values there, my answer is coming exactly equal to, what is it, the answer? So answer is coming, VC is equal to 15 multiplied by 500 multiplied by 1 plus 0.6. Right? So cutting velocity is coming 12 meter per minute. I have converted into meter per minute. Right? I have converted into what? Meter per minute. Answer will come in millimeter. Answer will come in millimeter per minute. I have converted into a meter. So that's what answer is given. So I'll say that, sir, my answer is exact. Delta D is perfect answer. Right, correct one. Delete is perfect answer. Okay. Now let's talk about one more question that is exactly equal to same. A 600 millimeter by 30 mm flat. So length of the stroke will be 600 and width of that particular machining operation is 30. That is what flat surface we want to machine, right? So it was written that a 600 mm by 30 mm flat surface of plate is to be finished machined on a shaper operation. The plate has been fixed with a 600 mm side along the tool travel. So travel direction of the tool is what 600. That is what the length of the stroke will come. If the tool over travel at each end of the plate is 20 mm. So over travel is what 20 mm. Average each end means what? Approach and over travel. Please point to be understood here. What is that? Approach and over travel has to be considered, right? Fine, because at each end, so approach and over travel will be 20 mm. Average cutting speed is 8 meter per minute. The feed rate is given 0.3 mm per stroke and the ratio of return time to the cutting time is 1:2, that is 0.5. Ratio of what? Return time to the cutting time. Return time to cutting time is 1/2. The time required for the machining will be. So how much time will be required for machining operation? This is what exactly question is. Can you able to calculate how much time is required for machining operation? How much time will be required for machining operation? Anyone? So whatever data is given, I'll write down that. So I'll say that the length of the stroke exactly equal to 600. What is that? Length of the stroke is exactly equal to 600 millimeter. And width of the workpiece is exactly equal to what? 30. Right? Whatever data is given, based on the data we are writing down. Right? Fine. Nora Fateh is 16, Nasim Khan 16. Let me check that what exactly answer is coming. Value of this particular cutting velocity is given 8 meter per minute. Please convert into mm per minute. So 8 meter converted into mm. So 8000 mm per minute. 8000 mm per minute. Is it okay, everybody? Yes. So feed value is given 0.3 mm per revolution or 0.3 mm per stroke. It is generally given like a stroke per stroke. Right? Fine. Now the next data is that the return stroke time to the cutting stroke time, it is 1/2, which is less than 1, that is exactly equal to m, because we know that cutting stroke divided by return stroke, cutting stroke time divided by return stroke time, that ratio is called as quick return ratio. But now it is less than 1, that is 0.5, that is m value, capital M. And machining time, so can I say that machining time is exactly equal to W by F, which will give me that how many number of strokes required, and multiply by L divided by VC into 1 plus M, which will give me time required for one stroke. So this value will give me time required for one stroke, and how many number of stroke will be calculated by W, width divided by feed, width divided by feed. I hope you are understanding this. So therefore I'll write down here, so machining time is exactly equal to width is exactly equal to how much? 30 divided by 0.3, L is exactly equal to 600 divided by cutting velocity is 8000, multiply by 1 plus m, and m value is exactly equal to 0.5. So therefore I'll say that, sir, machining time, how much is that? So machining time will be coming exactly equal to a 12 minute. Rajat, Swati, Nora, Nasim and all the students, Kiran, answer is coming what? 12 minute. 12 minute is the correct answer for me. 12 minute is the correct answer. Are you accepting 12 minutes is the correct one? Are you accepting 12 minutes is the correct one, my dear friend? Yes. Rajat Mishra, everybody? Yes. Super. So therefore, I'll go and say that, sir, 12 minutes is the correct one. Right? Right, fine. Next question. In a shaper machining operation, the mechanism of a tool feed. Tool is feeded in a shaping operation. Feed is given to what? Tool. Tool is feeded. So which mechanism is utilized for feeding of the tool? It is a Geneva mechanism or Whitworth mechanism or ratchet and pawl mechanism or Ward and subsystem is utilized. Which mechanism is utilized for feeding of the tool? So I think you are committing a mistake right? Whitworth quick return motion mechanism. Whitworth quick return motion mechanism is utilized for what? For maintaining the differential speed as far as cutting and return stroke is concerned. In the cutting stroke, I have to maintain the optimum speed because tool is engaged with the workpiece, and therefore the tool has to travel in optimum speed. During the return stroke, my tool is in not contact with workpiece, so it has to come back with the fast speed, and to maintain the differential speed in cutting and return stroke, Whitworth quick return motion mechanism is utilized. But whenever I am talking about feed of the tool, feeding के लिए can I say ratchet and pawl mechanism, my dear friend? Ranbir Paul, absolutely correct. Which one is that? Ratchet and the pawl mechanism is utilized. Kiran Kumar, not Bombay. Whitworth quick return motion mechanism is utilized for what? Cutting and the return. Cutting and return. Only in one stroke there is differential velocity, different velocities. Cutting optimum speed, return very fast speed. So therefore, can I say that my answer is exactly equal to ratchet and pawl. Feeding operation, ratchet and pawl. Nora Fateh is absolutely correct. C is correct. Kiran Kumar, please be aware of that. Right, fine. Next question. Now you tell me that in a Whitworth quick return mechanism, the velocity of the ram is maximum at what speed? At what position the velocity of ram is maximum? So tool is moving with optimum velocity, right, fine. And then at the return stroke, the velocity of the tool has to be maximum. But now where it is maximum? At the start of the return stroke, or at the mid of the return stroke, or at the end of the return stroke? Because cutting stroke will be always optimum velocity. So there is no question of optimum maximum velocity at cutting stroke. So return stroke, during the return stroke, maximum velocity will be there. Nora Fateh C, Kiran C. End of the return stroke? End of the return stroke? I don't think so. Is there anyone? Rajat Misra is also talking about C. Absolutely not. Middle of the return stroke. Middle of the return stroke. Why the middle of the return stroke, my dear friend? Whenever I start moving the tool, will it attain the extremely high velocity at the beginning? Velocity will gradually increase. Velocity will increase. At the mid of the stroke, velocity will be maximum. Velocity will be maximum, and at the end, velocity should be minimum. Now, because we have to stop the tool. We have to stop the tool. Do you understand that? What is happening? Whenever my tool is moving, it will gain some velocity. At the mid of the stroke, velocity will be maximum, and at the end, I have to stop my tool. If the speed is maximum, it will get collide, and there will be a fracture takes place. How is it possible to stop the two-wheeler or four-wheeler when the velocity is maximum? So when we reach to the destination point, we reduce the speed. Are you accepting, everyone? Nora? Is it true? So therefore, can I say that, sir, you need to understand at what? Middle of the return stroke. And this is not my question, was asked way back in production. And this can come in GATE examination mechanical. Right? So I hope you are understanding. Ranbir Paul, Farad, Swati, Naseem, Nora, Kiran, everybody. So can I say that my answer is to be what? My answer is to be at the end of the stroke. At the middle of the stroke, right? At not end and not beginning. Not end, not beginning. Okay, very good. Now some simple questions we'll try and solve in the drilling operation. Drilling operation is also one of the important, right? Fine. So what is it? The time taken to drill a hole through a 25 mm thick plate. There is a 25 mm thick plate is there through which the hole is drilled, rotating at a 300 rpm and moving at a feed rate of 0.25 mm per revolution. 0.25 mm per revolution. So what will be exactly equal to machining time required? 20 seconds? Is it 20 seconds required? Right? Kiran Kumar, Bombay B. Nora? So let's say that, sir, there is one metallic plate. Let's say that thickness of metallic plate is 25 mm, right? Fine, 25 mm. Now, point to be understand that, can I say that, sir, we have to consider whenever we talk about any kind of machining operation or drilling operation, there has to be a length of travel of the tool. That is what we're interested to calculate, because we know that the time of machining, how to calculate time of machining, length of the travel, L divided by F into N. F is nothing but speed, N is nothing but RPM, right? Speed at RPM, that is called as feed velocity. Distance divided by feed rate, feed velocity will give me a time. So how much distance that tool need to get travel? The total distance that tool need to travel, it has to be considered approach plus a compulsory approach, because in a drilling operation always compulsory approach will come, then the thickness of metallic plate, and then the over travel. Compulsory approach is must there. That approach is must, and the over travel is also must. Now, what is the definition of compulsory approach? I know that compulsory approach is exactly equal to d by 2 into what? Cot of beta. D by 2 into cot of beta. Are you accepting? But sir, cone angle is not given in the problem. Is the cone angle is given? No, cone angle is not given. Is it anything mentioned about the approach and over travel? Nothing is mentioned about approach and over travel. So when the nothing is mentioned, you don't require to panic, and I'll just simply say that, sir, approach, then compulsory approach, and then this over travel should be turned out to be what? 0. This has to be 0, consider 0. This has to be considered 0. So therefore, I'll say that length of the stroke will be only thickness of the metallic plate. That's it. Thickness of metallic plate, that's it. And therefore, I'll say that machining time is exactly equal to, how much it is? L. How much it is? 25. 25. Is it 25? Yes, 25 divided by speed, 0.25 mm per revolution. That is exactly equal to 0.25 mm per revolution, multiply by n. What is RPM is given? RPM is given 300 RPM, right? Fine. So machining time will come. But sir, I have to calculate answer in the second, and RPM is given revolution per minute. So multiply by 60, you'll get answer in a seconds, right? Fine. So time will come 20 seconds. Time will come what? 20 seconds. Is it true, everybody? Time will be coming exactly equal to 20 seconds. The answer is coming. Is it true? Yes. Nora Fateh, Swati Kumari and Kiran Kumar, absolutely correct. 20 seconds. Right? 20 seconds. Right? Fine. Okay, absolutely everybody. Yes. Right. 20 seconds would be my answer. This is my answer. Right? Fine. Next question in front of you. Right? Fine. An HSS drill of 20 mm, high speed steel drill of 20 mm diameter, high speed steel drill of a 20 mm diameter with a 5 mm cone height of the cone is what? 5 mm, is used to drill a through hole in a steel workpiece of 50 mm thickness. So there is a one plate whose thickness is what? Yeah, no worries, right. Cutting speed of 10 meter per minute and the feed rate of 0.3 mm per revolution is used. The drilling time in seconds, and neglect the approach and the over travel. Again, the approach and over travel is to be neglected. Again, what? Approach and over travel is need to be neglected. Right? Fine. Metallic plate thickness is 50 mm. Can you able to calculate answer? क्या बात है, absolutely correct. 69.12. Nora, Nazim Khan, you have to calculate spot on. So let's see that, sir. Whenever I'm interested to calculate a machining time calculation in a drilling operation, I know that it is exactly equal to L divided by F into N. L divided by F into N. Right. So what is the data given? I'll just write down the data. The drill tool is having diameter 20 mm. Right, fine. The cone height, can I say cone height is nothing but called as compulsory approach is given. If we talk about drilling operation, and just now we have talked about drilling operation here, if we go here, can I say this height is called as cone height, and the cone height is nothing but called as compulsory approach, which means that a compulsory approach is given to you. That need to understand. Compulsory approach is given to you. That is very, very important to understand. But approach and over travel is not given. Again, we neglect that. So whatever data is given, I'll use it. As simple as that. So I'll say that compulsory approach, that is cone height is 5 mm. Thickness of metallic plate is exactly equal to 50 mm, right? Fine, 50 mm. Feed is given 0.3 mm per revolution, right? Fine. But sir, I require RPM. What is the RPM of the tool which is being rotated, or what is the RPM by which the drill tool is rotating? But sir, what data is given? The data is given that the cutting velocity is given, that is 10 meter per minute. So I'll say that cutting velocity is given 10 meter per minute. 10 meter per minute. So can I say that this cutting velocity can be written as exactly equal to, cutting velocity can be written exactly equal to 1000 mm per I'll say that divided by 60, that is uh, minute per second, mm per second, right? Divided by 60, right? Fine. Now let me tell you that cutting velocity is given. What is the cutting velocity? Can I say cutting velocity is exactly equal to pi into d into n, pi dn, right? Divided by 60 if the diameter is given, or rpm, n is given in rpm, or if I want to calculate in seconds, so you can say that's the right, fine, pi dn. Pi dn, can I able to calculate this particular velocity? So I'll say that, sorry, velocity is given, so I'll say 1000 is the velocity. The pi, the diameter is given. How much is diameter? Diameter is 20. So can I get n value here? So I'll say that n value is coming, I'll divide it by 60 also. So rpm is coming exactly 2.6652, 2.652 or 652, that is exact revolution per second. It's not rpm, it is coming rps, right? Fine. Now you put it value here and the time is coming 69.12, 69.12, absolutely correct, 69.12, because I can write down here time is equal to length. Length is nothing but 50 plus 5, 50 plus 5. Approach and over travel has to be neglected, but compulsory approach has to be considered. 50 plus 5 divided by f into n, f is 0.3 and n value is exactly 2.652. Right? So answer is coming exactly equal to 69.12 seconds. 69.12 seconds. Is it okay, everyone? So these many number of questions I had today with me right now, right? Fine. So I hope so. Tomorrow we have one more session and the name of the session is casting. Again at the same 10:45. So tomorrow I'm thinking that I'll bring the questions from DRDO and ISRO and previous engineering services, where it will give a lot of learning, because all the previous year get questions or good questions we'll try to solve. Right, fine. So tomorrow we'll try to have one more blasting session, right? Fine, 45 minutes or 15, because I don't know, at midnight also students are studying. Absolutely bravo with your confidence and wish you all the luck. So see you tomorrow. Thank you for joining this particular session. Join the BYJU'S Exam Prep. It is one of the scintillating platform, and join a dedicated channel of mechanical civil engineering where there is no language barrier. All the Hindi and English particular sessions are conducted at one particular platform. So thank you everybody. Sir, great timing. Yeah, timing will be 10:45 p.m. tomorrow. Yes, Nora Fateh, thank you. Kiran Kumar, thank you. So take care of mental and physical health and keep rocking. See you tomorrow at the same time. Right, fine. All the best. See you tomorrow. Yes.